Welcome back. In this video, we're going to go over section 2.5, which continues our look at solving linear equations. But in the examples here, the equations all have fractions or decimals in them. And so we learn how to deal with that. So in our past sections, when we'd seen equations that had fractions in it, they were kind of carefully chosen so that just distributing was sufficient to remove the fractions. And we'll see in this section, it's not always the case and how to handle that. So one approach to take is just to apply the steps that we learned to solve the equation just with the fractions in there. And I'm going to do one example like that, and then we'll see another method also. So here we've got just a little equation. There's no parentheses or anything in it, and there's only three terms. It's 1/4 x plus a half equals 5/8. So how we would do this is we're going to collect the variable on the left side and the constants on the right. So that means that we should get that 1/2 out of there, right? So we're going to take and subtract a half from both sides. So let's do that. So the left side will be just 1/4 x, the right side 5/8 minus a half. A half is 4/8, so 5/8 minus 4/8 is 1/8. So then we have 1/4 x equals 1/8. So this is the part where we would apply the multiplication property to get just x alone. Right now, x is multiplied by 1/4, so we'll multiply both sides by 4/1. 4 times 1/4 will just give us 1, and the right side will have 4/8, which equals a half. So our solution is a half. Okay, that way will work, just doing the steps that we learned in the last section, just keeping in mind that our steps now are going to involve fractions. That's one way. Usually people don't like that way, as well as just trying to eliminate the fractions. And so that's the kind of approach that we'll take in this section. And so we're going to talk about how you do that right now. So notice the equations we have. We're going to redo the same equation just differently, okay? We have 1/4 x plus a half, that's equal to 5/8. Taking a look at the denominators that we have, 4, 2, and 8, the least common multiple of 4, 2, and 8 is going to be 8, right? That's the smallest number that 4, 2, and 8 all divide into. And so we're going to multiply both sides by that number 8. And as you know from working on things like this last equation, you can always multiply both sides of an equation by a number. We usually do it to help us solve things like this. We'd multiply both sides of 1/4 x equals 21 by 4 in order to make the x be a 1. But in this case, we're going to do it to make it so that the fractions all go away. So we're going to multiply the left side by 8. We'll have 8 times 1/4 x plus 1/2, and that will be equal to 8 times 5/8. Okay, so next we'll distribute the 8. We'll have 8 times 1/4 x plus 8 times 1/2. The right side, 8 times 5/8 is just a 5. 8 times 1/4 x is going to be 2x. 8 times 1/2 is going to be 4. Okay, now after that, multiplying both sides by the least common multiple of the denominators, the fractions are all gone. If there's any fractions left, then either you picked the wrong LCM or you didn't do a multiplication correctly. So from this step forward, it should be pretty straightforward. We'll subtract the 4 from both sides, and then finally divide both sides by the 2, getting 1/2. Most people will find this method of doing it easier, although you can't always do it the other way, just plowing into it with the fractions. We're going to do more examples where we eliminate the fractions by multiplying both sides by that LCM. So let's try that right now with this one. So we've got 7 equals, and then 3 terms on the right side that have denominators of 2, 3, and 4. So the LCM for 2, 3, and 4 is going to be 12, right? So we're going to multiply both sides by 12. If you picked a bigger number, if you multiplied all 3 together, getting 24, it'll work. It's just that you're going to have bigger numbers. So usually we want to pick the LCM. So we're going to have both sides times 12. So we'll have 12 times 7 on the left side, 12 times 1/2 x plus 3/4 x minus 2/3 x. Okay, 12 times 7 is 84, so that's done. And then we're going to have 12 times each thing. 12. Sorry about that. Zoom crashed on me once again. Okay, backing up just a hair. 12 times 3/4 x, and then minus 2/3, 12x. And that was it. Okay, sorry, that threw me off a little bit. Okay, so we have 84, and then 12 times 1/2 of an x is 6x. 12 times 3/4 of an x is 9x. And then minus 2/3 of 12 is going to be 8x. Okay, so now at this point, the fractions are all gone. We can just combine like terms. Here, 9 and 6 is 15. Minus 8 is 7. So we'll have 7x. Okay, let's try that again. So we've got on the left side just 84. And then on the right side, we have 7x. And so then dividing both sides by 7, x will be 14. So 14 is our solution. Okay, so that takes us to the end of that example. We saw that we could basically just multiply both sides by whatever the LCM of those denominators is, and that will make it so those fractions will go away. All right, so we're going to, that's the main idea for this action. We just need to try it a few more times. In this next example, there are 4 terms, 2 different x's, 2 different terms that are not x's. Our denominators here are 3, 6, and 2. And so an LCM of 6 looks like it will work. We have 6 times x plus 1/3. And then we'll have 6 times 1/6 of an x minus 1/2. Okay, so in this one, I'm going to distribute to remove the parentheses. 6 times x is 6x. 6 times 1/3 is 2. 6 times 1/6 of an x is a single x. And then minus 6 times 1/2 is 3. Okay, fractions all gone. Let me subtract a single x from both sides. Then add or subtract 2 from both sides. And finally divide by 5. So our solution here is going to be -1. Okay, let's try the next one next. On this one, I can distribute to remove parentheses or multiply both sides by 3. On this one, I think it will be helpful to just go ahead and distribute. I could multiply both sides by 3 to eliminate the fraction, but because I can see in the parentheses there's a 9 and a 6, both divisible by 3, I can think, well, it's just going to come out without any fractions in it just because of the distribution. So 1/3 times 9w will be 3w. 1/3 times 6 is just 2. Okay, and so that came out pretty clean. So it looks like our w is just 2 on this one. So on this one, it wasn't really too much of a necessary step really to multiply both sides by 3. If we had done that, okay. So I lost track of where I was at. Sorry. So if we do decide to multiply both sides by 3, we'll have 24 equals 9w plus 6. And so then subtracting 6 from both sides, we'll have 18 equals 9w. And so then w is 2. Okay, so it works out about the same in this case. Okay, let's try this next one. We have 1/5 times n plus 3. And then that's equal to 1/4 of n plus 2. So for this one, the 2 fractions that we have are fifths and fourths. So the LCM there is going to be 20. We're going to multiply both sides by 20. Note that if you were to do the distribution first, then you would have more fractions in it. So we're going to eliminate the fractions before using the distributive property. Okay, 20 times 1/5 will be 4. 20 times 1/4 will be 5. Okay, distribute to remove the parentheses. Then this time I'm going to collect the variables on the right side, just so that we can have a positive number next to the n. Okay, so 12 will be n plus 10. Subtracting 10 from both sides will give us an n of 2. Okay, and that will do it. If you had distributed in the first place, you would have just more fractions in it, but we would still end up multiplying both sides by 20. Okay, we have a couple of more. So here we're multiplying both sides by 6. The LCM of 3 and 6 is going to be 6. Okay, so then here, this 6 divided by 3 will give us 2. Notice that that 2 is multiplied by the entire binomial 4y minus 7. That gives us just a single y on the right side. Okay, get 8y minus 14 is equal to y. So then 7y minus 14 is 0. So 7y equals 14, or y is 2. So 2 is our solution here. We'll multiply both sides by 6 there. Okay, let's try this next one. In this next one, we're also going to multiply both sides by 6. One thing that you do need to be careful about is you need to multiply all of both sides by 6. It's a common mistake people will make to just multiply the fractions by 6. So they might get c plus 3 equals 2c plus 4. But here we have to multiply the entire left side and the entire right side. Somehow people will forget this 3. Okay, somehow. So c, 6 times c over 6 will be c. C times 3 is 18. 6 times c over 3 is going to be 2c. And 6 times 4 will be 24. Okay, let's collect the c's on the right side this time. So I'm going to subtract 1c from both sides. And then now we'll subtract 24 from both sides. That will give us negative 6 for our c. The point of that example, make sure we're multiplying all of both sides by whatever number we're multiplying by. Here's another example where we have to do the same thing. Here our LCM is going to be 6 again, so we're going to need to multiply both sides by 6. Okay, so now 6 times 3y plus 5 over 6 will give us 3y plus 5, and 6 times 1 is 6.